we start evaluating, again, the area between two curves, first thing to identify is which function is taking on the larger function value, which function is taking on the smaller function value. In this case, we still have two different curves we're considering. So f of x equals x squared minus 9, and the x-axis, which is the same thing as y equals 0. So what we're going to have happen, though, is depending on the interval that we're considering, from 0 to 3, the x-axis is taking on the larger function values, but then at 3, x squared minus 9 crosses over and it starts taking on the larger function values. So depending on the intervals that we're considering, we're going to have to evaluate some slightly different problems, or set up the problem in a slightly different manner. In part A, we want to evaluate the integral from 0 to 2. In that case, the x-axis on this interval is taking on the larger function values, and x squared minus 9 is taking on the smaller function values. So this will be very similar to match problem 1. We'll integrate from 0 to 2 of 0, since that's just the graph of y equals 0, minus x squared minus 9, the function that's taking on those smaller function values, dx, or we can rewrite this a little more simply as the integral from 0 to 2 of negative x squared plus 9 dx. So integrating will give us negative x cubed over 3 plus 9x, and then we'll want to evaluate this from x equals 0 to x equals 2. So evaluating this at 2, we'll get negative 8 cubed over 3 plus 18, and then evaluating that at 0 is going to be 0 and 0. So we just need to evaluate negative 8 cubed over 3 plus 18, which in this case will give us 46/3. So part A was very similar to match problem 1, but now in match problem 2, again, we have something more interesting or a little more complicated happening here. So for the first part of this interval, from 2 to 4, as we consider from 2 to 3, y equals 0 still takes on the larger function value. X squared minus 9 is taking on the smaller function value, but then again from 3 to 4, x squared minus 9 starts taking on the larger function value, and y equals 0 is taking on the smaller function value. So if what we're interested in finding is the area of these two regions, we're actually going to need to set up two separate integrals. The first will be from x equals 2 to x equals 3, so this first region where y equals 0 is taking on the larger function values. So that'll be 0 minus x squared minus 9 dx, and then plus the integral from 3 to 4. So now x squared minus 9 is taking on those larger function values. And then y equals 0 is taking on the smaller function values. So we're going to subtract 0 and dx, or with respect to x. So integrating this, or let's just rewrite it to simplify a little bit here. So this will be the integral from 2 to 3 of negative x squared plus 9 dx plus the integral from 3 to 4 of x squared minus 9. So now we have two separate integral problems to evaluate separately. This will be negative x cubed over 3 plus 9x, and we'll evaluate that from x equals 2 to x equals 3, and then plus x cubed over 3 minus 9x, which we'll evaluate from x equals 3 to x equals 4. So this will give us negative 27 over 3 plus 27 minus this exact same expression evaluated at 2, negative 8/3 plus 18, and then we're going to add the second expression evaluated at 4. So that'll be 64 thirds minus 36 minus that expression evaluated at 3. So we end up with this kind of long chain to evaluate, but then again, at this point, that's just a calculator operation to plug all of that in to get to a final result of 6. So part A, very similar to match problem 1, but now in match problem 2, we had to set up these two different integrals because there was a point on that interval where our functions crossed over and it switched which one was taking on the larger function values. Whichever function takes on the larger function values has to be the one that comes first in that integral.